Well, good day, ladies and gentlemen. Let's talk about our next section entitled Forms of Linear Equations. And you're probably saying, well, we've already got a form of a linear equation. In fact, in our last section, we looked at something like this. And we said this is a form of a linear equation called standard form. And it was helpful. It was helpful especially to find x and y intercepts. Let your x equal 0, solve for y, you got your y-intercept. Let your y equal 0, solve for x, and you got your x-intercept. 2 points, you can draw the line. So this is a rather helpful form of the line. But there is a more helpful form of the line called the slope-intercept form. And most of you know it looks like this. Y equals mx plus b. In other words, you have solved an equation, a linear equation for y. When you do, the number in front of your x is your slope, and the constant number at the end is your y-intercept. And you can take any line in standard form and find its slope and y-intercept simply by solving it for y. So let's solve this guy for y. That means get y by itself. Not 3y, but y, so let's divide everything by 3. Hey, y equals, here we are, negative 2 over 3 is negative 2/3. 12 over 3 is 4. So this line that I started out in standard form, I solved it for y, and I have determined that the slope is the number in front of x, negative 2/3, and the y-intercept is 4. Another way I could say the y-intercept is 4 is that it goes to the point 0, 4. Both of these say the y-intercept is 4. Many of your problems on 3.3 will ask you to express your final answer in slope-intercept form. That means solve for y. All right, and in this particular section, we're going to discuss a very important concept known as the slope of the line. Some of you guys are familiar with this. Others of you have encountered it, but maybe need some refreshing. The slope of a line basically means its steepness. It's slant. So as I look at this line, I go, that's pretty steep. If I imagine walking up a hill like this, I say that's very steep. But we're going to have to be more precise than saying not too steep, kind of steep, really, really steep. So we're going to have to be, in fact, mathematical about talking about the slope. That's where we get into this concept. And I know you've heard of it, that the slope is defined as the rise over the run, which makes absolutely no sense at all unless you realize that the rise means the vertical change and the run means the horizontal change between 2 points. So obviously in this line I have 2 points. We're going to define the slope to be the vertical change, and by the way, change means subtraction. If you made 90 on one test and 95 on the next, and you wanted to know the change or the difference in those two, you would simply subtract one from the other. Some of you have probably seen this representation of vertical change over horizontal change, delta y over delta x. Delta is the scientific indicator of change, the change in the y's over the change in the x's. So if I want to talk about the rise over the run, start with 1 point. Let's start with this guy here, and talk about the vertical change, the difference vertically. So to get from here to here vertically, I would go up 1, 2, 3, 4, 5, 6. And as you know, up is positive, up 6. So the slope of this particular line can be found by doing this rise over the run. The rise is 1, 2, 3, 4, 5, 6, up 6. The run, or the horizontal change between this point and this point, to get from here to here, I'd have to go 1, 2, 3 to the right. And 3 to the right, as you remember, is also positive. So I'd go 6 up, 3 to the right. Positive, positive. The slope of this line is 6 over 3 is 2. Slope of this line is 2. So we have a very specific number to talk about the steepness of this line. Slope of this line is 2. Well, there is another way, and in fact a way that doesn't require that I even have a piece of graph paper or a line drawn between 2 points, and it involves this delta y over delta x. Once again, the change in y is represented by a subtraction, so we could say it's y2 minus y1, change in x, x2 minus x1. You know what that means, right? It means I'm going to have to label my points x1, y1, and x2, y2. And once again, it does not matter which point you call which. Either one could be x1, y1. So let's use this concept to find the slope of the line between these 2 points. y2 minus y1 is going to be 8 minus 2. x2 minus x1 is going to be 6 minus 3. That's 6 over 3. What do you know? Same concept, 2. Here is your slope formula. Slope, and M is the letter designated for slope. Your guess is as good as mine as to why. M is the slope, and it is defined to be y2 minus y1 over x2 minus x1. This is the guy you want to have handy because we're going to be finding the slope of the line between 2 points. And we don't even need graph paper, don't even need to plot the points or draw a line, just simply plug into this formula right here. For instance, let's see. Well, I'll tell you what. Let's look at some specific slopes. And when I say specific slopes, I mean, first of all, the slope of a horizontal line. Well, if a slope is steepness, I'd say this guy isn't very steep. So let's see, let's use our slope formula to find the slope of a horizontal line. Now we're going to find the slope of a horizontal line, and you're going to be able to remember it, but should you ever forget it, you can always refer back to this slope formula. Hey, what do I need to use this slope formula? 2 points. So let's find 2 points on this particular line. Let's see. 1, 2, 1, 2, 3, 4, 5, 6. Here's the point 2, 6. 3, 4, 5, 6, 7, 6. I just picked 2 points. So I picked 2 points on this line, 2, 6, and 7, 6. I'm going to call one of them x1, y1. I'm going to call the other one x2, y2. So let's find the slope of this horizontal line. It's going to be y2 minus y1. That's 6 over 6 minus 6. And x2 minus x1. That's 7 minus 2. I get 0 over 5. Now here's where you either hopefully remember, or you can always use your calculator to find 0 divide 5 is, what do you know? It's 0. So the slope of this horizontal line, in fact, the slope of every horizontal line is going to be 0. So let's sum up the concept about horizontal lines. We've talked about them in the last 2 sections. Horizontal lines have a slope of 0. Check this guy out. Look at these points. 2, 6, 7, 6, 10, 6, negative 3, 6. This is where I remind myself of the equation of a horizontal line. Every single point on this line has a y that is 6. The equation of this line is y equals 6. So every horizontal line has a slope of 0, and the equation y equals something, some number. So every horizontal line will have a slope of 0 and the equation y equals some number. Another observation we made about it is the equation will have only y's in it. Even before you simplify it, it'll only have y's in it. So if you have an equation with just y's, it can be simplified to y equals something. That tells me it's a horizontal line, and I know from now on, this point on, the slope is 0. So this little corpus of information is going to be helpful to work some of our problems coming up. All right, well, how about a vertical line? Let's take a particular example of a vertical line and figure out what the slope is. Hey, the slope is pretty doggone steep. Hate to be climbing up this mountain, right? So let's take a couple of points on this line. 1, 2, 3. Might as well do 3, 0. 3, 3. And let's use the slope formula. y2 minus y1 over x2 minus x1. So again, pick a point, call it x1, y1. Pick a point, call it x2, y2, and fill it in. So y2 minus y1, let's see, 0 minus 3. x2 minus x1 is 3 minus 3. I get negative 3 divided by 0. I can't remember what that is. Let's see. Negative 3 divide 0 is, error. And that reminds me that I cannot divide by 0. I cannot have a 0 in my denominator because it makes no sense. It has no mathematical meaning. Error. So I get what's called an undefined slope. So when I have a 0 in the denominator, which I will always have with a vertical line, I get undefined slope. Horizontal line, slope is 0. Vertical line, slope is undefined. Hey, let's look at this particular line in more detail. Some more points. 3, 0, 3, 3, 3, negative 6, 3, 5. And I make this observation, hey, every single point on this line has an x that is 3. So I shouldn't be surprised that the equation of this line is x equals 3. So let's make a similar observation that we did with the horizontal line. For vertical lines, the slope is undefined. Second observation, the equation will always be in the form x equal some number. And another way to think of it is the equation will have only x's in it. Here is your important bit of information to remember about vertical lines. So typical non-horizontal, non-vertical line will have a slope that is a particular number. And for the record, this is the way positive slopes look, like your hope the stock market goes or your grade point average increases. This is the way a negative slope looks. Positive, going from lower left to upper right. Upper left to lower right is a negative slope. Horizontal is 0 slope. Vertical is undefined. All right. Now what we're going to do is basically work some problems in which I am given some information and asked to find the equation of the line. And typically when this section asks you for the equation of the line, it is asking in the form y equals mx plus b, slope-intercept form, unless it specifically says standard form. All right, find the equation of a line when given the slope and the y-intercept. Most of you are going, hey, this doesn't sound too difficult. Let's see, let's say the slope is 3, and the y-intercept is -2. All I have to remember is the slope-intercept form. Y equals mx plus b. Hey, I've got m. I've got b. So all I have to do is substitute. Y equals 3x plus a -2. We typically write that as -2. Hey, that wasn't too hard. Give me the slope and the y-intercept. All I have to do is substitute for m and b, and I have the equation of the line in standard form. All right, try another one. Let's say the slope is -1, and it goes through the point 0, 7. Did that confuse you? This is another way of saying the y-intercept is 7. Any point, 0 anything, is a y-intercept. When x is 0, it's on the y-axis. So this is another way of saying the y-intercept is 7. So with that in mind, y equals mx plus b. Y equals -1x plus 7. More commonly write that y equals -x plus 7. Hey, here's the first challenge. Find the equation of a line when given the slope and the y-intercept and you go, hey, no brainer. I got it. Not a problem. All right, try this one. Find the equation of a line when given a point and the slope. Now, this point is not the y-intercept anymore. It's just any given point. So let's see what we can do. Let's say we give you the point 8, -10, and the slope is 6. I still refer back to this, y equals mx plus b. Look here, I got 1, 2, 3, 4 different variables in this particular equation, and it looks like all I have right now is m. Looks like I don't have anything else until I realize this very important concept. Anytime I give you a point, I have given you an x and a y, right? Every single point is an x and a y. So I now have an x, a y, and an m. An x, a y, and an m. I have everything but b. So substitute for x, y, and m, and solve for b. Let's see what this looks like. Y is -10. M is 6. X is 8. Plus the only thing I don't know, b. -10, 6 I made is 48 plus b. I need to get b by itself, so minus 48 minus 48. Look what I got. I've got the y-intercept, and I've got the slope. That takes me right back to scenario number 1, slope and y-intercept. So all I have to do is fill in the slope, fill in the y-intercept, and I have the equation of my line. Y equals m times x plus b. How about that? So if I got a slope and a point, I have a slope and an x and a y. In other words, in my equation here, I have everything but b. Substitute, solve for b. Okay, let's try another one. This is one right off your Hawks, which means it's probably not going to come out even. That dot there is for free, no charge. All right, I got a point, I got a slope. With my point, I realize I have an x and a y. So I'm going to fill into y equals mx plus b. There's my y. Make sure you keep these straight. Slope 2/3. X is -11 plus b. And here's where I have to remember some of my common arithmetic functions or concepts, like multiplying a fraction by a whole number. If I make that whole number over 1, it becomes easier to think about multiplying because I simply multiply the numerators and the denominators. 2 times 11 is 22. 3 times 1 is 3. Positive times a negative is a negative. Got to get b by myself. So I'm going to add 22/3 to both sides. So I get 5 plus 22/3 equals b. Recall this. to add fractions, they have to have the same denominator. So I'm going to change 5 to thirds. 15 thirds. Now I can combine these two fractions. They have the same denominator. Just add the numerators. That's 37 thirds. So B is 37 thirds. I told you it wouldn't come out even if it was a Hawk's problem. So there's my y-intercept. Here's my slope. Here's the equation of my line. Y equals m times x plus b. All right. Major concept to remember is if I'm given a point, I have been given an x and a y. Let's look at a couple more examples from this scenario, a point and the slope. In fact, let's look at the point 4, 5, and slope is 0. All right, here's where you can either work hard or you can work smart. One thing you should notice is I've got a slope of 0 here, right? Go back to your notes. Slope of 0 means I have a horizontal line. And every horizontal line has the equation y equals something, right? Slope is 0.